Yeah, please. We don't want to do that again.
Yes.
It says recording, so you good.
Not fun. When I lost it.
Oh, still says recording.
Yeah, but yeah, we're fine
Okay.
tonight for sure.
All right. Again, I have to make excuses for myself tonight. My cough, I don't know if it's a COVID shot that did it or just it's getting worse, but I'm going to cough through this meeting. So if I hit the cough button, forgive me, and we'll go on. I'll go ahead and call the meeting to order, 7 o'clock. This is a regular monthly meeting of the Richmond Amateur Radio Club. Let's go ahead and do introductions. Ken, I'll start with you. And I don't know if everybody's got the same order of faces on the screen as I do, but let's everybody just go ahead and identify yourselves one by one. Ken, you take it first and then I'll take it.
Okay, I'm Ken, WV0L.
And I'm John, K5HTZ. John Portune, why don't you give us yours?
Yes, John Portune, W6NBC.
And John is our guest speaker tonight, as y'all will find out in a few minutes. Greg, go ahead.
Yeah, I'm Greg Kenley. I'm KC1NRJ, and I'm in both Boston and Richmond, so I'm here for the winter.
Good deal. JB.
I'm JB Edmonds and 4NQI.
Okay, Bruce.
Bruce McAllister, W4BRU.
And Deborah.
Debbie Howard, I'm K04JGW.
Okay, Tom.
Tom, KG4BIZ.
And Gerald Sneed.
I go by Jerry, KO4HFX.
Oh, thank you. Win.
Win, W4WIN.
Okay, John. John King.
John King, WB4NHX.
Lauren.
Hi, Lauren Ware, WD4FMG.
Okay, and Ellen and Daryl.
Daryl, WW4F.
Kathleen.
KN4UMD.
And I see an Ed W. Give us a call too if you have one, or if you're just a guest, that's fine too. Just let us know.
Hey. Ed Sprengel. I'm just got my call sign, but I don't even have it memorized yet and don't have it with me.
Okay.
So I'll have it next time.
Oh, congratulations on getting your call. All right, Dwayne.
Okay, this is Dwayne, KK4JNN.
All right, and Dr. Rick.
Rick, KA40HM.
And Dave Thomas.
Great call.
Delta 3 Oscar.
And William James.
Good evening. I haven't gotten my call sign yet. I'm starting class in March. Kind of late to the game, obviously, at the age here, but
And never too late. Never too late.
yeah, I've been trying to do this for about 30-something years.
Well, we're glad you're giving it a shot. We hope we can help you. Okay, Mark Robinson.
Mark Robinson, N4MDR.
Okay, David Elkins, you there?
David K4QN, nice to see you all tonight.
Good to see you too. Mike KO4MEZ.
Yeah, this is Mike. I just got my license about 2 weeks ago and got an invite for tonight's meeting. One of the things I'm interested in learning. That's basically it.
Good deal. We're glad to have you aboard. Brian.
Yeah, Brian Davis, KJ4KVH.
And Tim. Well, Tim's not answering, so anyway, he's with us. Oh, there's Bill and Judy. Hi, guys. Okay, so let's go ahead and start with our business for the night. First of all, our first order of business is that is Dave, the approval of the minutes. Everybody should have gotten a newsletter by now. And does anybody have any questions or corrections or anything for the minutes? All right, none heard. I'll go ahead and ask for a motion from somebody to approve the minutes. And a second.
Second.
Okay, all in favor?
Aye.
Treasurer's report, Ken.
Okay. We started the month out with $15,866.19. We had $60 worth of dues, so 3 people renewed or joined, as the case may be. And then we paid for the storage garage, and then we paid for our domain name for the website. And the expenses came to $61.16. So we lost $1.16. So we're at $15,865.03. So not too bad.
Okay.
for
Do we
that.
have any new members to bring in tonight?
We do.
Oh, you just muted yourself, Ken.
Let me move the keyboard. I got a cat on the lap, so she's out of camera range right now. At least that's the good news. We got Philip M. Springler, who does not have a call sign, or is that you, Ed?
That's me. I have a call sign. I just don't know it yet.
Oh, you don't
in my
know.
email.
So is it with the FCC? Are you Philip or are you Ed?
Ed.
You are, okay. Hence why I couldn't find you, because I went out and looked to try to find you. So anyway, we got him. A new person just got his call sign. We have John Dietz, KO4KTV. He is a, wherever it's at on here, technician. I knew it's there somewhere. Lauren Ware, WD4FMG, a general. Gene White, W4CKP, who is a general also. We have Tom Garnon, KMKOT, who is a general also. And John Rawls, N4VME, who is an extra. So do I have a motion to accept these people?
So moved.
Anybody second?
Second.
All in favor?
Aye.
Okay, well, let's notify them that they are now members of this exclusive club.
Okay, and I have 2 people who caused me a minor amount of grief in that they changed their call sign. David Cooper, he used to be K04W or JWV. He's now KN4DFL. Happened on December 29th. And David Lebisky was KN4SYJ, is now N1VNV. Also happened on December 29th. So congratulations, Guy, for your new call signs. And if anybody wants to contact him, take note of the new call sign.
Okay, thank you, Ken. Any other business from the treasurer for tonight?
No.
Okay. See, I don't know if Alan's with Alan Johnson. Are you with us tonight? Okay. I know he was having computer problems. I want to go ahead and give you all some information that Alan gave me. We talked to him during the week about the what the procedure was going to be for collecting fees. It's not that the FCC is going to be charging fees for licenses. What Alan told me is that if you take a test from him, he will send your paperwork in just like he normally does to the ARL on Monday morning or whatever, over the weekend, whenever he sends it in. Pardon me, the FCC, once you get into their database, will give you 9 days to log in to your FRN, whatever it is, account and pay the fee, the $35 fee. If you don't pay the fee within 9 days, you have to go back to the volunteer examiner and get them to recertify your test. Your test becomes null at that point, and you have to go through the certification process. So we need to remember that if you have a fee due, you need to pay it within 9 days. The other, I think that was there another question about it too? I'm trying to remember now. I believe that was the only thing. Anyway,
You can't pay ahead of time, right? They won't let you pay ahead of time?
From
before
what
they-
I understand, no. Now on renewals, excuse me, renewals you may need to. Or I remember the other thing that he told me to. Make sure that you check with your in the FCC database to make sure that you have a current email, because they will not send any postal mail anymore to you. If you have anything from the FCC, it's going to come to you by email. So you have to have a current email address on file with them. So be sure everybody check and make sure that your email is good. Otherwise, you'll liable to miss something that you just can't afford to miss from the FCC. I think that was everything that Alan had. Did everybody get the message about QSO Expo? QSO Expo.
Yes.
Well, can somebody report on it for me? Anybody know enough about it to report on it? Because I'm having a problem talking here. Ken, what I can do, I can send you the expo information, and I think it may be in the newsletter. I believe I sent it to Armin, and it's in the newsletter. But if you need it, if you need a copy of the QSO Expo information, give me an email, and I will get you a copy. That's the easiest way to handle it. But I think everybody
signed
should
up
have.
for it because of it was in the newsletter.
It was?
The newsletter, yeah, and then I went to the link and signed up for it.
Okay, good. Anyway, if anybody else doesn't have it in a newsletter, let me know and I can get you a copy. Next month, we're going to have another speaker who is going to tell us about the Virginia QSO party. It's time for the Virginia QSO party again. So, Ken, we sponsored one of the certificates this year, didn't we?
Yes.
Yeah, okay. So anyway, he's going to be our speaker next month. Tell us about the rules and everything. Let's see. I guess I'll go ahead on to Bruce. Bruce, you want to give your reports?
Okay. First thing I got is about the school. Registration ends on the 23rd of February. So far we have 8 for tech. So we know we're going to have that class, which John is going to teach. I've seen enough other email coming in with people asking about it. I think we're going to be more than 8 by the time we get set. We have 3 for general. We need 1 more to make the class. I think there's a fair chance that'll happen by the 23rd. So I think we'll have a general class. I don't think we're going to have extra. So far, we only have 1 signed up. I don't think we're going to hit that one. Which brings me to my second thing, which is if we don't have an extra, then I'm probably going to do a class on a 2 or 3 night class on setting up and using the club's remote control station. So those of you who are interested in learning how to do that and getting set up for it, I'll plan to do that. That assumes I don't have a surprise and we get a bunch of extra students. The third thing is I did a piece on ham pie last month. The guy the W3DJS has come out with Ham PC. It's the ham pie group of 80 plus ham apps that will run on any kind of a Linux system you got. Number 4, if any of you are voters in the city, we need you to get a hold of your city council person. Richmond, along with a number of Tidewater and Northern Virginia communities, put together a distracted driver law because the state couldn't get their act together. Unfortunately, it did not have any exemption for hams. We now have the new state law that has exemption for hams. So we need to get rid of the city ordinances and the county ordinances. Around here, it's only the city that has it. So I've written my city councilor. I've got 3 or 4 other hams who have written theirs to get them to basically get rid of the ordinance. So the state one, with the exception for hams, takes force. And the last thing is, John got a call from a teacher, middle school teacher in Hopewell. She wants to do an ARISS session, a space station connection. And you have to have a ham radio club to be part of that. So we're going to do that, assuming she goes forward with it. I'm looking specifically whether we have anybody around here with the equipment to really do, if they do EME, that sort of thing, they got the equipment to do a direct connection. We can do a telephone connection, but a direct connection is desirable. We tried to do that with the Science Museum, and as Tom and I learned, it isn't a simple thing to do. You got to have somebody who does this regularly and has the equipment to do it. So if you know any hams that do EME that want to be a part of that, let me know, and we'll get them set up. We'll do it direct. But in any case, I'll be back to some of you all for volunteering to help with that. So that's all I got in my report.
Okay, thanks, Bruce. Let's see. Is Dr. Joe or anybody can give us an ARL report tonight here? Okay, well, we have the local Virginia ARL people are sending me bulletins. If anybody's interested in the bulletins, give me an email and I'll shoot you a copy of what I'll probably end up putting together a mailing list. Generally, Dr. Joe, when he's here, gives us a rundown on what ARL's doing. But if you're not getting those reports directly from the section manager, you can always shoot me an email and I'll put you on my list to get forwarded copies of it. All right. Anybody got a show and tell for tonight? No.
I have one.
Okay, go ahead.
This is a Wolf River coil called the Silver Bullet 1000. And it comes, I got what's called the Take It Along version that comes with a 102-inch whip. It comes with a little tripod and three 33-foot radials, and it works 10 through 80. And so I'm going to try this out as soon as we don't have any ice.
Okay, let us know how it works out.
What is it called?
It's by Wolf River Coils. There's a couple hams out of Wisconsin that make these. It's just a coil and a PVC pipe and this sliding coupler here. It's similar to, it's like based on a, what do they call them? The mobile
Screwdriver.
Screwdriver.
Yeah, like it's a manual screwdriver. I'm going to experiment with it for as soon as the weather gets nice, for my portable stuff with my IC705.
What's the power rating on that, Rick?
I believe it's 200 watts continuous and maybe 100, or 200 watt sideband and 100 continuous.
No, not bad. Okay, let us know how it works out.
Now they make a higher power version called the Platinum, but they come with comes with a little tripod you can set up. Comes with radials, so it's a little bit more robust than the coil that came with some of the stuff I had seen from MFJ. And I'm going to use a bigger whip on it and see if it maybe try center loading and everything. But it comes with a 102-inch whip that will work for. You have to shorten the whip for 10 and 6, but it's supposed to work for 80 and 40 and 20.
Okay, good. All right, thank you. Anybody else have anything that they want to either show us or talk about tonight before we go on to our program?
I have one. Am I on mute or am I talking?
You talking?
Okay. Ed, you are KO4GZB.
Yeah, I just found it in my email.
Oh, okay.
Yeah.
Okay. Anybody before we go on?
I have a question. Can
Yeah.
Bruce say again what it was he was going to teach 2 or 3 nights a week, so I can ask to be signed up for it?
Yeah. How to use the club's remote station.
Okay, thank you.
Yeah, we welcome everybody signing up for that when it comes that Bruce decides to go ahead and do it. All right. Well, tonight we have a very special guest. We have an author who's well recognized in the field. He's written articles in QST and a number of other places. I think he has some books out and stuff. So he's going to talk to us tonight about balance. So let's everybody welcome John Portune.
Okay, let me go to screen share here. Pick up my audio and let me recommend to you before I begin this, if you're seeing all the little thumbnails to the side of your screen, I recommend you turn them off so it doesn't block some of these slides. The way you do that is just go to the top of the thumbnails and there's a little minus sign, looks like an underline. Click on it and it'll turn off the thumbnails. Okay, let's go up here. Oh, come on. That's blocking the, there it is, slideshow from the beginning. Okay, we got it. Well, today, I first of all, are you all hearing me?
Yes.
Yes.
Good. Okay, that's fine. Today we're going to talk about the coiled coax Balun. Many of you may know it by the name of ugly Balun, and it can be ugly, but we're going to step beyond the mystery of this antenna because although a lot of hams know about it, they really don't know how to deal with it or how to put it together. And that's what I'd like to show you today. I wrote an article in, I think it's 2 months ago when it was, oh, no, this month, the current one, February 2021. And by the way, if any of you'd like to do me a favor, go to QST at ARRL.org /cover/plaque/poll, cover plaque poll with hyphens in between it, and vote for the article. Just does me some good with QST. I wrote this fairly simple, plain article about it. We're going to go into a good bit more of it tonight here about how to build your own one-to-one coax choke balance. Okay, many of you, and perhaps most hams, particularly if you're on HF, are aware of what you see here. This is an ugly Balun, as it's called. But not too many hams really know how to put one of these together. Somebody's got their microphone not muted. Okay, but how do you design one of them? That's the issue that we want to deal with today here. It looks fairly straightforward, and it is, but there are some things that you need to know about designing this correctly. Because you need to know how to choose the diameter of the coil. You might think, well, I just get a piece of PVC pipe and throw some coax on it. Yeah, that'll probably work, but maybe not as well as you think. And therefore, you'll need to know the diameter, the number of turns, how long to make it, and then there are some special choices that are determined by band. So we're going to look at all of those characteristics here. Well, here's some Baluns that I've made. These are all, by the way, 2-meter Baluns, as you can see in the middle of the screen there. On the left is the most familiar, what you'd call the typical PVC solenoid Balun. I like to do it this way. As you can see, I've drilled holes through the PVC. Sure, you can use tie wraps or glue. It'll work too, but that to me has always been the easiest way. Just drill some holes at the side at an angle so that the coax will pass through. This is also a good way if you want to make the Balun in your mast. If you're using a PVC mast, this is a real good way of just putting the Balun in the mast right below the antenna. And then at the bottom left, you'll see what's typically the bundle. Now, many HFers know this, the 6-inch 4-turn bundle of coax. Well, it works on all bands, and that's a 2-meter version of it, about a little over 1 inch in diameter with about 3 or 4 turns, held together with zip ties. My favorite is the one up at the right, in which is the famous Taurus knot. And that's simply made by taking the coax, winding a loop, and then shoving the end through the middle to cause it to form into that intertwined torus. It doesn't need any tie wraps, and you can change the size of it if you want. It's a very convenient way. I very frequently, when I don't have a Balun made up, I just take the coax and whip a torus up. It works very well. More recently, however, since I have owned a 3D printer now for about a year, a Prusa i3 Mark III's, wonderful machine, highly recommend it. I love 3D printing, and in fact, I'm writing a section for the next ARRL handbook on 3D printing. But there's one of my little 3D printed forms. Those are really easy. You just take it, drop the coax in, shove it over, and then cinch it up, and you got a Balun made out of this. I have them in 2 or 3 sizes. If you want the STL file for it, if you have a 3D printer, I'll be glad to send it to you. You'll get my email later in the presentation here. Okay, so those are 2-meter Baluns, but you can make them for all bands. There are 3, however, essential design concepts when you're going to put together one of these coax Baluns. And they're simple concepts. I don't like a lot of math and heavy theory. I like the theory and can handle the math, but I like the intuitive approach. And that's what we're going to look at today, some 3 intuitive design principles. Concept number 1. Now, at a recent ham breakfast, I got up and asked everybody, okay, who will tell me what the primary purpose of a Balun is? And I got a lot of blank looks in my face. And only one person even got close. Most people have the wrong impression of what a Balun's for. They have the wrong idea. And I'm going to tell you what it should be. I believe the term Balun, which comes from a combination of the beginning of 2 words, balanced, unbalanced. I believe it's a very poor name. I wish it had never been given to this device because it leads hams in the wrong direction. It has little or nothing to do with classical balanced, unbalanced. It really is a coax line choke. And that's the main job of a thing, to choke off current on the outer shield of coax. That, in effect, does do a balanced, unbalanced. But to me, it's the wrong name for the device. Now, because, frankly, when you're feeding an antenna with coax, the current inside of that coax is just as balanced as the current in the antenna that you're feeding. It's just the same. Coax is a balanced line with a shield on the outside of it. That's all. It's really not unbalanced in the sense that most people think about a balance. All right, let's look at the principle here. Most people don't realize this, but coax is a 3-wire system. It has a separate 3rd conductor. It's the outside of the shield. The stuff that we want to do happens inside, but there's a 3rd conductor outside. You might say, but it's the same as the shield. It's just 1 conductor. No, it's not. It's 2 conductors because skin effect makes the outside and the inside of that shield separate conductors. So current can be flowing one way on the inside and a different way on the outside, or both on the same. And that's what the Balun, or the choke, the coax choke, is for, to get rid of that current on the outside. And how does it get there? Well, you see it very clearly in this diagram. There's a dipole, a vertical dipole, hooked up to the shield and the inner conductor of coax. And that's fine. Those are both the currents in those 2 are balanced. But unfortunately, at the end of the shield, there is a connection from the inside of the shield. Comment? I heard some noise. Okay. There's a connection at the end of the coax where it meets the antenna, where the current coming back from the antenna can not only go back down the coax, but it also can go back down the shield. The ends of coax are the inside and the outside of the shield are connected together. The working current happens on the inside of the shield. The unwanted current happens on the outside, and that's what a Balun is for. I call a Balun a coax choke. That's what it is. It can also transform impedances, but that's a special kind of Balun. But the basic function of a Balun, if anybody ever asks you, is to choke the current off the outside of coax. As you can see here, the currents in the antenna up there symbolize red and blue, flowing back and forth. The current that comes back from the side that's connected to the shield, it goes down the inside where it belongs, but because of that connection at the end, it also flows down the outside. Remember, those are separate conductors. 3-wire system, coax. The reason for the choke is that it's to choke off that outside current. Now, I frequently get a question from hams. where are you supposed to put all these ferrite chokes if you put them on your line? You put them just outside of your window? Do you put them in the middle of the coax? Or the chokes go up at the end, right up at the antenna. You can put them down at in the bottom, but they do the work up at the end. They want to stop that reverse flow on the outside of the coax. The chokes must first be at the antenna. If you want more of them somewhere else, fine. Doesn't hurt anything, but at least have them up at the antenna. I know it's heavy, it's ugly, but that's what it's got to be. Now, how does the thing work? Well, the idea is very simple. There are several methods to do it, ferrites and coiled coaxes and so forth. But the way to stop the current on the shield is to place a choke, well, that is a high impedance, in the outside conductor, in the outside of the shield. And then it will block the current, won't allow it to happen. This is, of course, why if you don't have it, your outside of the shield can radiate, and you don't want it to do that. And you can do this by ferrites, or you can do it by coiling the coax, but at the antenna. Okay, that's how it works. Concept number 2 now. How much coil? That's the question, the second question. It's fairly easy to answer. It can be rather mathematical if you want it to be, but I'm going to cut through the mathematics and talk about it pragmatically or intuitively. But technically speaking, the coil that's made by coiling the coax needs to have an RF resistance, or better known as an inductive reactance, X sub L. It's a resistance in ohms. It's just an imaginary resistance, but real. Okay, here's the principle. That reactance, or that RF resistance that you make by coiling the coax, needs to be somewhere in the range of 4 times up to 10 times the system impedance. Most of all our antennas work at 50 ohms. So it wants to be 4 to 10 times 50 ohms. In other words, it wants to be somewhere that the coil of coax wants to have a reactance, or an impedance, of somewhere between 200 and 500 ohms. I recommend that you don't go more if you don't have to. More may work, but it can also have some difficulties. So remember that figure, 200 to 500. In the article, I suggested 200. That's minimum. It works fine. But somewhere between 200 and 500 is what you really want. You want that coil in the shield, made by rolling the coil in the shield. The inner coax will ignore it, or ignore that coil entirely, but it will be a resistance or an impedance or a reactance in the outside of that shield of 200 to 500 ohms. Okay, here's the classic formula. You don't have to figure, oh, I got to do a lot of mathematics. No, but here is the classic formula, in case you're wondering. The inductive reactance of a coil is 2 pi times the frequency times the inductance in henries. That's the formula. For 500 ohms, it works out as 6.28 times the frequency of the band times the inductance in microhenries. Microhenries and frequency of the band in megahertz, the micros and the megas cancel out. And it wants to equal 500 ohms. Now that table on the left, which you don't need to try to remember, or you don't need to try to write down, I just did an Excel spreadsheet, and I figured for 500 ohms of reactance made by coiling the coax, here's the amount of inductance in microhenries you're going to need on the various bands, 160 up through 440. As you can see, it decreases, of course, as you go up in frequency. Now, once you've got that inductance, once you know that inductance, and I'll show you an easy way to get it here in a minute. Once you know that inductance, you can either read it from a table like that one, or you can figure it out for yourself. Once you know that inductance, that how many microhenries you need in the coil, you need to figure out how many turns and how big the thing is. So you need to use this formula. Again, you don't need to work this math. I've just put put the formula down there in case any of you are math types. I am, so I like formulas, although I rarely use them. I'm like Einstein. He wasn't bad at math. He just let somebody else do it for him. So that's the formula. The inductance in microhenries that you're looking for is the radius squared times the turn squared divided by 9 times the radius plus 10 times the length. It's a classical old formula that you can find in any radio book. But you're going to need that to now find out how to make your coil. I don't bother doing the math. The internet is so good at helping you do math that I don't even bother. I go to this little source every time I want to make a Balun. You can see the URL down there. It's a British site, Electronics 2000 in the UK. Their calculator, their reactance calculator. Here's how you figure out how to get 500 ohms at the frequency you want to work at, or 200 ohms if you wish. 200 is the minimum, 500 is probably a more ideal size. So here you can see I've run this little calculator, which you can get there at that URL if you're curious and want to write it down. Here's the example I had in the article for 160 meters. You want to make a 160 meter Balun, 1.9 megahertz. So you put in the 1.9 megahertz, but you don't put in 500 ohms. You got to work this calculator backwards. That's what's a little difficult for some people, is it's got to be worked backwards. What you got to do is you got to guess to start with at the number of microhenries. So I put in 10 to start with. I did the calculation and it turned out to be the wrong number of ohms. So I've changed it to 20 and put it in again, and it got closer. And then I put in 30 and 40. And finally, when I hit around 40 ohms, when I hit around 40 microhenries, I got close to 500 ohms. So I tweaked it a little finer, started putting it at 40, 41, 42. And when I hit 42 microhenries, I got 501.398. That's perfectly good. So you got to work this calculator backwards, but with a little effort, it's no problem to do it that way. Here's the other calculator you're going to need. This is also was in the article. If you want those URLs, they're in the Feburary QST on the article. Then you have to work this calculator backwards too. You have to set it to microhenries, and you have to work this backwards. Unfortunately, here you've got to do a conversion from inches to centimeters. That's not too difficult, but some people that's a little uncomfortable. It's being a European calculator. Everything's in centimeters. So, but most people can handle it. 2.54 centimeters to the inch. You have to do this one backwards too. You have to guess at the number of turns. Then you have to figure out for that number of turns the length of the solenoid, and that's just the number of turns times the diameter of the coax you're using. You got to put in a radius for the coil. Try it for 1 inch or 2 inches or 4 inches. And relative permittivity, that's 1. These are air coils. Then hit the calculate, and it'll give you a number of microhenries of inductance. You know what you're looking for. You got it from the first calculator. So you keep changing all those 4 values in the upper until the number of microhenries hits close to the amount you need. It's just a little busy work, as my physics professor used to say. It's just turning the crank. But these 2 little calculators are what I use when I figure out balance. Here, in fact, is the 160 meter example from the article. It's, by the way, up on the website QST in depth, which you can get if you want it. But I worked these things. The number of turns, solenoid length was 10 centimeters because the diameter of the coax was 1 centimeter. This was RG Mini 8, and so it was 10 centimeters long, 10 turns. Coil radius 7 centimeters, and the relative permittivity again 1. And when I finally got those numbers in and worked it backwards, I got 19.344 microhenries. I needed 19, so that was what I used. 10 turns, 10 centimeters long, 7 centimeters in diameter, worked it back to inches. Okay, Here's a table that I compiled with those two calculators. It's the number of turns. You don't need to write this down. If you record the thing, you can go back and look at these numbers if you want. So here's the number of turns that you need for a 500 ohm reactance coil by band. All the bands, 160 to 440, and on various diameters of PVC pipe. You have to look up the diameter of the PVC pipe and put it into those two calculators, and it shows the number of turns you need on those sizes of pipes to give you the amount of inductance or reactance you need on these bands. Like I say, this is a table. If you want the table, I can send it to you, but you can find it if your leader there is recording it. Okay, concept number 3. This is rather important. Most people who build these coiled coax balloons don't pay attention to this. Coils have self-resonance. All coils have in them both inductance and capacitance, or what's called self-inductance and self-capacitance. And that makes every coil that you make a parallel tuned circuit. It is a parallel tuned circuit by nature. And what does a parallel tuned circuit have? It has a natural resonant frequency. That's important when you make these balloons because you need to stay away from that natural resonant frequency. This is an important concept in building these balloons. It's not hard to do. It's not hard to do, but I want you to understand the principle. Okay, here's your coax. We're looking at the outside, not the inside, the outside of the coax. And the outside of the coax has along its length, it looks like resistors here, but those are actually coils. All pieces of wire, whether straight wire or coiled up, have inductance, natural inductance of a piece of wire. It's there, you can't do anything about it. And when you wind it into a coil, the turns next to each other have capacity to each other. That's distributed inductance and distributed capacity. And they go together in the classic formula for resonant frequency, and every coil has a natural resonant frequency, including that coil of coax you build on the outside to make a balun. Here's the curve of that natural resonant frequency of your coiled coax. Here's the natural frequency of it. You'll notice something rather interesting. Below the resonant frequency, that coil of coax acts like an inductor, which is what you want. But above the resonant frequency, it acts like a capacitor, which is exactly what you don't want. So obviously, you need to stay in the inductive range of that coil outside. You don't want to wind a coil that has a natural resonant frequency right where you want it to choke off the shield current. That's the thing you need to remember. It's not hard to do by rule of thumb, but that's just the principle behind it. Here's the simple way. If you want to avoid self-resonance in your coiled coax balance, make the coil square. Now, how do you make a square coil? No, I don't mean make a square coil. What's a square coil? It's simply a coil that has the same height as its diameter. That's a square coil in coil parlance. It's not the fact that you wind it on a square form. It's a coil that's about as high as it is wide. And if you make a coil that's square, about as high as it is wide, you won't get self-resonance. Which means don't try to make a 160 balun on a piece of 1/2 inch PVC. It's not square. It's going to be anything but square. And it probably will do exactly the wrong thing. Okay, taking that chart that we saw earlier, it has regions on it. And those regions are where you probably can stay out of self-resonance. If you're going to do an HF balun, use larger diameter form to do it on, or a larger diameter bundle. I usually like to use as large as possible. So for HF balance, I like to go up to 4 inches or even bigger than that if you can get the form to wind it on. Or of course you can make the coil bigger if you want, if it's just a torus wound coil in the air or with tie wraps. But you can make HF balance, as you can see here, down to 1 inch diameter forms. I recommend bigger, but these are acceptable and they should keep you out of the range of self-inductance. And I recommend using RG8 coil, a coax, but Mini 8 and RG58 will work. Okay, you can see the two. On the right is the RG8, and on the left is the Mini 8, which you can make smaller coils out of Mini 8 on smaller forms and still stay out of self-resonance. Here's the same thing. Here's the same thing for 6 meters. 6 meters, you only want to make it out of RG8, 58 or 8, and then you want to make it on a small diameter of somewhere between 1/2 inch and 2 inches. You don't. You can make a 10 meter one for 6 meters out of RG. You might anyway. You see what this means. Keep your 6 meter coils in smaller coax and in smaller diameter, and so that you make the coil square. Here's the 2 meter ones. Obviously, you don't want to make them too big in diameter, and 1/2 inch PVC, 6 turns, 5 turns on 3/4, 1 inch. This is commonly what I use on the mast of a 2 meter antenna. I've shown it in the articles many times. Much the same on 220, just 1 turn less. And on 440, you really want to stay down small. So here are your basic 4 methods of making the coax balance. The common one of made on an antenna mast or just on a piece of PVC with holes in it. That's a good way, but as I say, I like it because you can put it right below the antenna if you make a PVC mast, or zip tie some turns together, or make it into a torus knot. I like the torus knot, do them all the time. But these are 2 meter balance and they're all the same scale here. So you can see they're fairly small. That's a piece of 3/4 inch PVC, I think, on the left, and my little 3D printed form. And finally here's the last Balun I built, and it's for a 6 meter antenna. Pardon the fuzzy picture, this is just part of it, but it's a 2.5 inch diameter, 5 turn 3D printed square coax Balun out of Mini 8 for a 6 meter antenna, the article of which will appear in QST in a few months from now. And finally, the final thing is, here's a good way also to hold Baluns together. I've used this a number of times. In fact, once you use it, you can take all the things holding it together off. You can take it off the form, or you can take the zip ties off, or whatever. You go down to the local hardware store and buy some of this Permatex super clear vinyl adhesive. It's made for patching up vinyl chairs, but it's wonderful for gluing vinyl coax together. And so if you want to, you can make your Baluns out of vinyl jacketed coax instead of polyethylene jacketed coax, which is a little higher quality jacket, but vinyl is pretty good too. This is better. I know a lot of people might think of using that typical acidy smelling kind of self-curing stuff, silicon sealant, but this vinyl stuff works really good, and it's really very weatherproof. Anyway, as Roy Rogers would have said to you, happy trails to you until we meet again. And here's my little doggy, Lolly. No, she does not have a German call sign, but I say she does, D0GGY. And that's it, folks.
Okay, thank you very much. Anybody have questions or Anything you want to ask?
Yeah, I have a question because I know so little. I've just barely got my technician's license. What are the other kinds of balance that or the special kind you said that this wasn't?
Well, balance can be done in a number of ways with stubs and other things. But the most common other Balun that hams run into are 4-to-1 or 9-to-1 balance, so often used with long wires. They work the same way and they do the same thing. They're still to choke off the current, but they also perform a transform of impedance, which is another function. They act as an impedance transformer as well as a current choke, but their primary function is still to choke off that outside current. They can also do that transform. So if you like to run a long wire, for example, which is a long non-resident antenna, sometimes a 9-to-1 coax Balun is often used, or a 4-to-1. The coax Balun is easy to make into a 9-to-1 and 4-to-1. You just hook 3 pieces of it together, one end in series, one end in parallel, and it works quite well. I don't mean to cover the different kinds of Baluns, but that's where the other kinds kind of come in.
Yeah, okay, thank you.
Anyone else? Okay, well, John, we thank you very much for being with us tonight and appreciate the nice presentation. Definitely some good information.
Okay, I'm happy to do it for you. I'd be glad to talk again anytime you like. Lots of topics coming up. And I am, by the way, speaking at the QSO Expo today. Expo in March 13, 14, Saturday, Sunday. Just register online, QSO Expo today. And I'm talking on an antenna that I recently did, which is very, very popular. It's called the double inverted delta slot antenna. And it's a vertical that's horizontally polarized and has gain. Have you ever heard of a vertical with gain? Have you ever heard of a vertical that's horizontally polarized? Well, this is one. It's a low noise vertical. That's what I'm talking on at the Expo.
Okay, what could you tell us some about the Expo? Do we need to register, or how does one get into it?
Yes, you need to register. There is a fee to attend. It's not modest fee, but you just go to QSO Today Expo, Virtual Expo. Just search for that on the internet and you'll find the registration place. Very straightforward. And there'll be the list of speakers and the various sessions that you can attend.
Okay, great. Thank you very much. All right. Well, does anyone else have any business for us tonight?
I got one more question for John.
Sure.
The Balun that you made with your 3D printer, could you make more for other people? I mean, could they buy some from you?
Well, I'm not in the business of selling stuff. I'm retired. I don't need a business.
We always have 3D printers. That's all.
Well, actually, John,
you probably do know. You probably do know how to.
If you're willing to send the files for stuff, you can go to the public library and print them.
Yeah, public libraries have them. Local maker spaces have them, and you probably have somebody in your club that has a 3D printer and will be glad to print for you.
All right, thank you. Thank you.
Yeah, but if you want to send, now my email, I don't think I gave it to you in this presentation. You want to write my email down, I'll be glad to correspond to you and send any of the stuff you want to you. My email, if you want to get a pencil and write it down, is my name, J for my initial, Portune, Portune, J Portune, at AOL.com. Or you can also get me at W6NBC at ARRL.net. I have the forwarded email there too. And if you have a 3D printer or would like to get the files so that you can get somebody, you can buy them at many number of sites and so forth. So forth. I don't want to go into the business of printing things.
No, I understand. I just thought if you were some people do, and I just didn't. I thought I'd ask. That's all.
Yeah, sure.
John.
Yes.
Would you mind if you sent it to me or to our president, John? if we put it up on our website for people to download?
No, absolutely not. I'm in no business. I'm in not protecting anything. If you want to use any of the things I have, they're all yours. If you'd like, I can send you the STL file. Did you record this?
Yes.
Did you record this? Yeah, you should make the recording available. So if people would like those little turns charts, and I'll be glad to forward to you. Does it go to you, Ken?
Yeah, you can send it to me. My call sign is there after my name on the screen. WVZL.
I have your email address.
Okay.
I also have John DeMaio's email address. I'll send you both the STL files in case you want to print these forms. I think I have 3 of them for various, mostly for VHF, UHF. I don't have any big ones for HF, but they could certainly be done.
Okay. Yeah, we can put them up on the website, and that makes it accessible. As he said, I know Chesterfield and Henrico Library both allow you, if you bring in the file, to make the stuff. Henrico, I know, charges you for the material. Chesterfield used to not, but I think they have now done it because it became too popular for them. But it's
local
not expensive.
Local colleges often have 3D printing classes. If you have a local community college near you, you'll probably find they're teaching 3D printing, and will very often make their printers available to you. Or the local maker space. Search in your area for a maker space. You're likely to find one, and they almost always have 3D printers.
Right. All right. Well, thank you again, and we enjoyed the presentation. Before we close out for the night, does anyone have anything that they need to bring up or anything?
I do.
Go ahead.
Hi, Judy and for JDI. Robin has a question, and I'm not seeing Robin's call sign, but
That's right.
it says, could we ask John to come back and give a talk on a more elementary subject that New Hams can understand?
Yes, I understand. This one was a little bit for the more advanced hams, and I'm wide open to doing lectures and talks on almost anything. If you've got a particular thing that you say, I'd really like to know about this, just tell me. I love putting together presentations, and there's so much in ham radio to be talked about. Believe me, that to grab one out of thin air is a little difficult. But if something is puzzling you at all, even if it's the most elementary idea, don't hesitate to ask me. I like to do presentations.
Okay, that brings us to another subject about the same kind of thing. Bruce and Ken and I have been working on a new ham survival kit. It's just about completed. We have a few maybe corrections or additions to make to it, but it should be available in the coming month. So anybody, all of the new hams that are needing advice on what kind of radio, what kind of antenna, whatever, how to set your station up, safety precautions and things. We'll have this little kit that also gives you a band chart and some other things that that are available to you normally online, but that your new ham just may not know where to go look for them. So expect that'll be coming out soon.
Also, David LQN has put together a packet. I'm sure you can request that online. KC4TS, we do testing once a month on the first Saturday. And you can probably get in touch with him and request one of those for different nets in the area, times, frequencies, repeaters, that type of thing. So there's
actually, Judy, he sent me a copy, and we're kind of sharing information. So
excellent, very good. Okay.
We'll have.
So now you're a ham. Now what?
Exactly. Okay. Well, if there's no other business for tonight, I'll go ahead and close the meeting. Yeah, go ahead.
I got a question for you.
Sure.
I'm Thomas, and I'm a new ham, and I sent my application in for membership in January. Is there anything else I need to do to become a member, or is there some sort of
send $20? It's a question of the mail. I went tonight, oh, you are. We voted on you tonight.
Oh, okay. I was a few minutes late getting to the meeting. I'm
So
sorry.
no, you're officially in.
Yeah, you're
Okay.
officially in. I was looking, I was going, I thought I remember that name. So yeah.
Well, I thank you.
Welcome to our club.
Yeah, I thank you. Thank you so much. Looking forward to being a member.
Okay, well, yes.
One more thing. It's Lauren, WD4FMG. I was going to ask, has anybody been in the club since the early 90s? Because I found an old roster of the Richmond Amateur Radio Club from 1994, which was the last time I was a member. And I just wondered if any of you all had been members way back then. I've been off the air probably a good bit of time since then. So I just wondered if there are any 1994s left.
There are, but you got to turn on your microphone, Tom.
Let me look here a second.
The club might want that for posterity, right?
KG4BIZ, there he is. He's been there forever.
Tom, you muted. Tom, your microphone's muted.
Tom, push your space bar down.
Yes.
How about that?
Perfect.
Okay, gotcha. Lauren, I have a list somewhere here in my archive of better than 400 that was in the club, 440 plus back in the day. It may even be what you have, but I thought it was so neat. I did give a copy back as I was president years and years ago. I did give a copy of that, but I think I may have kept the original. And it's just fascinating to see how many were in our club at one point, years and years ago, even before I became a member in the mid 90s.
Actually, Lauren, the club is, I think, over 100 years old right now.
Yes.
And we actually have stuff in our archives. Ken mentioned about the storage facility we have. We actually have files in our archive going back almost to the founding of the organization. So there is a lot of archival information out there about the club and things that have happened over the years.
One other thing, we had two people that are still members who joined back in 1981. So
it's me.
Well, the list I have has 156 people on it.
This had over 400.
Yeah.
And very interesting. And like I said, if anybody's interested in any of that information,
I have to
from the archival stuff, we can try to make it available for you to look at.
It should be in the archives there.
Yeah, it is.
It should be.
You can take a look.
As a new member now, is there like a directory, a club directory, or something to look at?
Ken, what do we have?
I have a roster of everybody who's in the club, and I make periodically, basically when somebody says, can I have a list of the directory, what I call a public version, which is takes away when you paid, how much you paid. One of the things we have is what year was your birthday and how old are you effectively because of that. I take that out so people don't get to know.
And the reason we collect that information is because when you are 80 years old, you don't pay dues anymore.
Yeah,
or you don't have to
pay
anyway.
dues anymore. And then the other thing I do is I'm trying to remember the keystroke here. I do a stat on what's the average age of a member, how long have they been in the club, and things of that nature, so that we get a decent feel for that type of information. So, but I clean all that out. But if you'd like to have a a copy of that, as I say, a public version, I can make that available. I don't put it out on the website because there was a copy out on Google of the effective, well, the roster was actually out there, and we got spammed pretty decently. Somebody wanted to, they said John couldn't do something and he needed some money and go to the store and buy some Visa cards and send the numbers here and whatnot.
Yeah.
And,
Yeah, we don't like to publish
we don't
people's
like to
private
publish
information on the
things like
web.
that happening, but if you'd like one, Lauren, I will run down your email address and send you a copy.
Yeah. I'd like to let everybody know too, just a reminder, most of you know already, we have stuff. If anybody needs some stuff, give us a call, and it's very possible we may have what you need in our storage. We have people constantly giving us, donating to the club, leaving us estates and things that, that may be of interest to some people. So, if you need a piece of test equipment or, radio that you want to clean up and fix and use, we do have some, as I call it, stuff. So give us a call or an email. All right. So anybody else have anything before we close? Then I will ask for a motion to close this meeting.
Motion to close.
Second.
All in favor?
Aye.
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 Okay. Good night, everybody.
Good night, everyone.
Good night.
Good
Thank you.
seeing you.
Get it.
All right, thank you.